Hello guys. Today we are discuss JVM architecture. The JVM architecture is the basically the follow the JVM the internet data structures. So first is the class file. The class file is the basically we have the write the program and the compile and generate the class file. After that the class file will be load to the class loader subsystem and class sub loader subsystem we will see the in the detail in the future in the next slide. And the another is the there is a store the all the memory, the variable and everything. We have those the separate memory of the name is the method area, heap area, stack area, PC register, native method stack, education engines, native interface, native method laboratories OS. So there is all the component the JVM the internet architectures. So we will see the one by one. So first things is the load the class file. After that, this class file is the loading and preparation and the all this the perform. After that, this all the store the values, the different the method area, heap area, stack area, PC register, native area. After that, the educate engine and the get the result the OS the output. So we have the discuss first is the class loader subsystem. The class loader subsystem the responding to the three categories: the loading, linking, and initialization. The loading also have the some component to the bootstrap class loader, extension class loader, system class loader. The linking is the verification, the representations, resolutions, initializations is the basically the last. So first we discuss about the loading. The loadings means the read the class file and store the binary data of the method area. For the JVM, the store the following the method area is a full of qualified names loaded node, fully qualified name of the immediate to the parent. Whenever the class file related to all of the class interface name, method of modify information, variable and field information, field the information constant all this. So after loading the class file, the JVM will be the object, the type of the represent to the class level, the binary information to the method area. Linking. The linking is the perform the three activities: the verifications, preparations, and resolution. The verification, the name of the suggest there is the sum the verify to the suggest to the sum of the verify. So it is the process of the ensure the binary representation the class is the structure to correct or not. It is a JVM will be checked to the class file the generated not the compile is the corrected not everything. Internally, the byte verification, the part of the class loader subsystem responsible for the activity. The verification is the fail, the get the exceptions, the class dot line dot verification error. Preparation. In the place of the JVM, they locate the memory, the class level, the static variables, and assign the default value. Is the not the original value the assign the initialized base. Resolutions. The resolution the process that replace the symbolic reference to the load of the original reference. The symbolic reference is the directly assign the searching the method area to the locate the entity. For the above the class and the class loader the subsystem the test class loader system the student and object and name of the this is the constant the pool of the test and the resolution the paste to the replace to the symbolic value to the original value. Initialization the it is the pace of all the static variable will be the assigned the original value. Static variable will be blocked to the educate the top to bottom and parent to child. Note the while the loading the linking and initialization any errors comes the get the runtime exception to the java.lang dot the linkage error. So the verification is the child of the linkage the error only. The types of the class loader. The every class the subsystem that contain the three activity: bootstrap class loader, the extension class loader, and the application class loader. So bootstrap class loader, this is a class loader that is responsible to load the all the from to the JDK, JRE, the lib folder. So all this the core Java API to the RTA.jar. There is a present to locate the all the API, and this the is the string buffer the load all the bootstrap class only. So it is also is the package is called this package is also called to the Java packages the by default available the method. So there is a loaded the bootstrap class loader path. The bootstrap class loader is the responsible to load all the bootstrap path. Bootstrap class loader is by default available as JVM. It is provided by defaults and it is the implemented by the native C plus templates. And another is the extension class loader. Extension class loader is the child of the Bootstrap class loader. This class loader is responsible to load all the extension path in the implemented by the Java and the corresponding to dot class file. It is the sum of the extension. So it is we have the extension class loader. We have to generate the sum of the developer to the sum of class and then check this path. Application class loader and system class loader. This is the child of the extension class loader. The class loader is the load to all the application the class and it is the internally the environment of the variable the class path. The application class loader the corresponding dot class file. It is a check to the extension the file is the class is loaded not and there is a loaded the system the path of the load. Various memory of the area of the JVM. The While the loading, the running, and the Java program JVM memory with the several things, the byte, code, and variables. So the total JVM memory is organized to the different categories: the heap areas, method area, Java stack area, PC register, and native method stack area. So the JVM will be the store the all the value the different depend upon the variables the and the define that the value. So method area. The method area is the contain the JVM startup. It will be the share the all the thread. It is a memory where the needed, not the continue. Method area is the constant the runtime constant pool. The total class is the binary information to the static variable the store of the method area. So the method area is the basically the store the static variables related all the information inside the method area. Heap area. Heap area is the completely the opposite with the stack area because the heap area the store the runtime object the it will be program views the consider the instead of the memory. The heap area will be the created the runtime when the startup. Heap area can be assigned to all the thread. Heap area other when need not the continue. All the object corresponding to the inside variable to store the heap area. Every array is the store the object and array is the store the heap only. Stack memory. The every of the JVM we will create the separate the runtime stack. So runtime stack will be created automatically the runtime of the thread creation. All the method call the correspond the local variable the immediately the results the store the stack. For every method is called the separate the add to the stack and there is the stack is called the framework. After the completely the method thread there is a remove the stack. After the all this the method the remove after the terminate the thread will be the destroy the JVM. The data storage in the stack is the corresponding to the thread and not available to the other thread. So JVM is the JVM is the store the each of the method we store the one thread the separately and that the there is the inside the store the value of the all the thread is the stack frame. The stack frame the structure is the each of the three components divided by local variable array, operand stack and frame array. The local variable array is the all the parameter local variable array is the method. There is slot with the 4 byte. Value the int float the reference only 1 byte the array. The value will be the long byte the two of the entire array. Byte short the value corresponding to type occupy the one slot. But way of the storing the boolean variable JVM to JVM, most of JVM the one entity and one of the slot of the value. So that the local variable the array will store the all this value inside the JVM to JVM of the each of the. Another is the operand stack. Operand stack is the stack of the workspace. The sum of the instruction the push to the operand stack and some instruction the pull the value the operand stack to performing the operations and the store of the value the again the stack. Frame data. Frame data is all the symbolic reference to the store the constant push the method. It is also reference the section table to the corresponding the PC register area. It is not the pointer to the programmer mostly. So sometimes we have to develop the PC register so that the JVM will store that value. For the every of the thread we will separate JVM per PC register to create the creation time and the PC register the address to the current of the instruction. Once we instruction the educate the completely the PC register we will increment the address of the next of the instruction. Next is the native method stack. It is the we have to use the external method of the that time will be used. The for the every of the stack JVM will separate native stack. All native stack will be involved to the corresponding the method area. Note the method area, heap area, and stack area consider the nature of the area with respect to the programmer view. The method area, heap area are the JVM. Whenever with the stack area is the PCL register native area are the stack of the thread. So one of the one separate thread of the heap of the every of the JVM, one separate thread of the one separate of the method area of the every JVM, one of the separate of the stack of the every each of the separate view to store stack area. The education engine. This is the center component of the JVM. The education engine is responsible to educate the Java class file. Education engine is the two component in the Java file, the interpret and JTI compiler. So interpret is the mostly used the every time the only the ones we have to educate the each of the code, and that interpret the is the problem is that you have the first time the educator again the repeated the multiple times, so that the reduce, so we use to the GTA compiler. The main of the GTA compiler to improve the performance. The internet GTA compilers is the separate the count, and the each of the JVM will be the store the any or call. The first time will be the interpret. After that the GTA compiler will be the responsible to call. The process will be the every of the method the same. So once we have the count the reach the threshold, the JTA compiler identify the method is the repeated so used to the spot. The immediately the JDA compiler the method area to generate to the native code, and the next time we will JVM the across the call directly use this code and educate the interpret and they improve the performance also. The thresholds count the various file JVM to JVM. Some advance the JTA compiler recompile the generate the native code threshold the reach. Second time show that the optimized will be the generated. The profiler it will be the JTA compiler response to the identify the hotspot. The JVM the interpreter total program line of the list once and the JTA compiler to the only repeated code will work. That's it. Thank you.